Hey guys, so this is part 2 of pages 630 and 633. So in this video, we will be covering specifically pages 632 and 633. Now before we get started, make sure you leave these pages in your book. Do not tear them out. I repeat, do not tear the pages out of the book. Say it with me. Do not tear the pages out of the book. Okie dokie, make sure you have your highlighters and your pencil ready. Let's get going. So, at the top of page 632, it's elementary. Oh my gosh. So, copper, oxygen, and mercury have one thing in common. They're all elements. What exactly is an element? It's part of elementary. Duh. No, it's not. Okay, with your pencil, I need you to underline active reading. As you read these 2 pages, draw a large E, capital E, next to the names of 5 elements that are described. Okie dokie, I'm going to start reading the paragraph. I need you to follow along with me. There are many kinds of matter. An element is the type of matter made of just one kind of atom. All atoms of an element have the same number of protons. For example, boron is an element. Every atom of boron contains exactly 5 protons. No other element has atoms with exactly 5 protons. What's so special about protons? Well, electrons are far from the nucleus, so they can be gained or lost. Also, different types of atoms of the same element contain different numbers of neutrons. But protons stay the same. Okay, now we're going to highlight some stuff. Now, in orange, you are going to highlight the definition of an element, which is the type of matter made of just one kind of atom. That's in orange. In pink, you are going to highlight what's so special about protons. And then you're also going to highlight in pink, protons stay the same. Okay. In blue highlighter, you're going to highlight electrons go far from the nucleus so they can be gained or lost. Last but not least, you're going to highlight in green. Also, different atoms of the same element can contain different numbers of neutrons. Okie dokie. Now, you're probably like, I kind of understand where that's going, but you're probably like, I also kind of don't understand. Let me break it down for you. Okay? Oops, so sorry, I didn't mean to draw. Okay, so let's just look at these 2 elements at the bottom of the page. But before that, there's one thing we have to talk about. Democritus up here. Yeah, at the top of the page. So, his little quotation that he said for today is, in the mid-1800s, I organized all known elements by their properties and increasing mass. Scientists still organize elements based on my work. Well, okay then. In yellow highlighter, you're going to highlight organized all known elements by their properties and increasing mass. Now, elements. Elements are one thing, okay? So let's look at the bottom of page 632. Okie dokie. Now, you probably already see my E next to neon and mercury. Go ahead and write a big E with your pencil next to each one of these. Okie dokie, I'm going to do mine. Now, these are elements. Now, remember, an element is a type of matter with just one kind of atom. Now, let's look at neon. Neon has 10 protons. Okay, no other atom can have just 10 protons. Okay, neon is used in neon signs, helium neon lasers, neat, television tubes, yeah, like the actual tubes behind the television screen, and for a refrigerant. It's not completely inside a refrigerator, just FYI. But there are different things neon is used for. Now, if you look at the middle of, I'm going to erase my E's really quick because I know you can still see them. I'm going to zoom in on this atom for neon. Okie dokie. So, if we look at the atom right here, here's the atom, here's the nucleus. So inside of that nucleus, we know that there's only 10 protons. Could there be more neutrons? Possibly. But let's count the electrons on the outside. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, understand this. When it comes to the atom itself, these little things that we circled on the outside with our pencil, they can be gained or lost. So what that means is some of those electrons can go away, and that neon atom can still survive. So it can have maybe 5. So let's erase all that we have out here. Now just know, if this neon atom, quote unquote, only had 1, 2, 3, 4, 5, 6, 7 electrons, it could survive. It could be just fine. Okay? Does that make sense? Okie dokie. I'm going to erase that and we'll move on. Okie dokie. Now, let's go over here to Mercury. Mercury, whoa, that's big. It has 80 protons. Oh my gosh, man. Well, what is it used for? Mercury is used in laboratory instruments, thermostats, yes, like actual thermometers, dental fillings, what? And pesticides. Who knows what a pesticide is? They use that whenever these are used, when farmers go through their crops to make sure what doesn't get on them? Yeah, bugs. Okie dokie. So we definitely have to be careful. Okie dokie. Now with that being said, let's just look. Okay? Let's look at the size of this nucleus. Whoa, my goodness. Yes, I know I just said, whoa, my goodness. That is so big. Now, we can see it with our own eyes. But an actual atom, mercury atom, we can't see unless it's under a microscope. Now, that means there's 80 protons. Is there 80 neutrons? Yeah, just about. Okay. Now, there might be like 78 neutrons, but that's okay because it can still survive. Ready to move on? Okie dokie. What? These are types of elements too? Yeah. Before we get into that, take your big blue highlighter and draw an X on the box on page 633. Whoa! Awesome. Free pass on 633. Okie dokie, let's look at the top. Okay. Before we get into copper, silver, and chlorine, an orange highlighter. Elements are substances that can't be broken into simpler substances. Say that with me. Elements are substances that can't be broken into simpler substances. Interesting. Okay, so from here, let's look at chlorine first. We'll go to chlorine, silver, and then copper. Okie dokie, chlorine. How many of you know what chlorine kind of does already? I know I do. Have you ever swam in a swimming pool that has chlorine in it? Yes, I have, for sure, because it makes my natural blonde hair green. Ah! Yeah, I know. That's one of the side effects of having blonde hair, but it's okay. So, chlorine. How many protons does chlorine have? 17. Okay? Remember, the protons always stay the same. That's what makes the chlorine element so special because it only has 17 protons. Okie dokie. So, chlorine is used for disinfecting water. We already kind of knew that. Making paper. Wait, what? paints. Whoa, that's cool. Plastics and dyes. Dyes. This is kind of like color dyes, if that makes sense. Okie dokie. Let's look at the size of the chlorine element. That's not too big, isn't it? It's kind of small. Yeah, you can see the neutrons in there as well. Now, is there a lot or a little of electrons? There's kind of a middle ground of electrons. It's definitely more than the neon, right? Definitely, for sure. Okie dokie. Now, one quick thing. I know you can already see my E for element on all three of these, but these are what? If I'm putting an E next to each one of these things, this means that each one of these things is what? A element. Okay. Silver. That is one messed up E on silver. I'm sorry. Okie dokie. Silver. Silver is typically used in jewelry. We kind of knew that. Silverware. We definitely knew that. Photography. Wait, really? Welding. Yes. So welding, solder, yep. And mirrors. There's silver in mirrors? Yes, there is, my friend. Okay, let's look at the size of the nucleus. Wow, that's definitely bigger than chlorine. But how many protons are in silver? 47. Yeah, good job. Make sure you underline these too. Okay. Ready? Let's go down to copper. I know my E's are messed up. That's okay. Okie dokie. So, copper. Copper is used in plumbing. Y'all probably already knew this. It's in coins. What is the most copper? I'm sorry. What is the most common copper coin? Any guesses? You already see it on your paper, don't you? It's a penny. Yeah. The penny's right there. Okie dokie. It's also used in electrical wire, which is very common, and making brass and bronze. Huh. Who knew? Okay, let's look at the size of the nucleus. Circle this with your pencil. That's a pretty good size, but how many protons are there specifically? 29. Now remember, the protons tell you how big that element is. Okay? Okay, now that we've gone over that, let's kind of brainstorm some more elements. Because why not? Now, what do we drink all the time? We drink what? Water. Okay, water. What's another name for water? H2O. What does the H stand for? If you said hydrogen, you would be correct. What about the O? What does the O stand for? If you said oxygen, O-X-Y-G-E-N, you would be exactly right. Now, hydrogen and oxygen are elements. You're probably like, wait, what? Yes, hydrogen and oxygen are elements. Make sure you write that down. Hydrogen and oxygen are elements. Okay? Write that on the box where it says draw and label carbon atoms. Okay. Now remember that because that might be on your test coming up. Okie dokie. One last final thing. Okay? One last final thing. Private message me the answer to this question. What is at the center of an atom? Now, if you private message me this answer, you might just get an extra point on your homework assignment. Okie dokie, I will see you guys later. I miss you so much.